Swayam Prabha. Digital India. Educated India.
That's it. Okay. The Gauss-Newton algorithm becomes the basis for several nonlinear problems. So actually, there's no need for a functional form. There is no need for you to be able to differentiate analytically, all that. And so this is the basis for the approach to a nonlinear world. Any problem you want to use an iterative technique. How you start with the current state and proceed to the next state. But when you're proceeding to the next state, you are using some derivative information and so on. So therefore, there is a general siddhant, there is a general philosophy associated with this. So it's a very, very powerful algorithm which is independent of whatever be the nature of your equation and so on. It can be extended to multiple parameters, this thing and so on. Of course, there are alternatives to this. So instead of the Gauss-Newton algorithm, the optimization course, if you've taken course race biology, would have taught, or I was teaching that course for 18 years. I'm going to teach it again in August. So we teach other techniques like simulated annealing, genetic algorithms. There are many other heuristic techniques, meta-heuristic techniques, which are available to handle this problem. Please note that essentially we are trying to minimize the S. So this inverse problem is treated as the inverse problem is posed as an optimization problem where there is a minimization. What is the minimization? The minimization of a residue, or the sum of the squares of the residue. What is the residue? The residue is the difference between your simulation and the experiments. Okay, temperature, heat flux, strain, whatever, stress, whatever you're measuring. Okay, that if you can analytically solve, it's very good. That's what we did in the least square regression. Directly, one stroke, dou S by dou A equal to 0, dou S by dou B equal to 0. You got a nice set of equations, but it is not always possible to do that analytically like that one shot. So therefore, we resorted to nonlinear regression where we have an initial guess and then we proceed from the initial guess. So in order to make the concepts very clear, as is my practice, we always follow up a theory with some particular example. So this Gauss-Newton algorithm, this example will follow throughout for the next 2 weeks, because other variants or variations of the GNA, which I'm proposing to teach, we will take off from this example and see how the improvements can be done. So this gives you a working knowledge. Otherwise, you get a theoretical knowledge. You feel you understood. Nothing you can understand this world properly without doing it yourself. Finally, whatever remains is whatever, not what you've learned, what you've done. What you've heard will also be forgotten. What you've done on your own, with your own hands, that is what will finally remain. Okay. Now, let us say that there is some experiment which is going on, an unsteady experiment. You're getting the theta. Theta is t minus t infinity. T infinity is not even required because we've already taken care of the t infinity and subtracted from t. So there are 6 values, serial number 1, 2, 3, 4, 5, 6. So there are 6 times. At these 6 times, there is a particular value of theta I, which is all these are measured. Okay, these are all measured. Now, what is the goal? What is the inverse problem? I know that it follows this form. This comes from the forward model. My knowledge of domain, my domain knowledge of heat transfer, whatever. I know that theta follows this, but I don't know what that A and B are. I already proved to you. I proved that this cannot be linear race. You can make it into a linear regression and do it. Therefore, we have to proceed with a non-linear regression. So, in order that you do a non-linear regression, you have to start with an initial guess. Okay. Therefore, people. The discerning student, the careful student will already realize that the solution will be a strong function of the initial guess. The solution also will be a strong function of the nature of the derivatives, dou t by dou A and dou t by dou B, how they vary, and whether these derivatives are sensitive to the initial guesses and so on. These also will decide the fate of this. So whenever there is a gradient-based algorithm, so it's going to be critically dependent on the nature of the matrix, that is a Z, and the nature of the initial guess. So there is a good chance the Gauss-Newton algorithm can also diverge. So please don't get carried away. Whatever you learn somewhere, something is very intellectually appealing, some prof is teaching you, you immediately assume that is the be all and end all. With that, you can solve all the problems in the world. No. Different techniques will work for different problems. So finally, the idea of education, you have to sift through all what you have taught, all what you have been taught, and then for your particular problem, you should be able to pick and choose some particular technique And if it is not sufficient, you learn a new technique. So this is the synthesis of knowledge. Because in life, nobody will give you question paper and ask you to solve it and grade it and give you grades and give you certificate. You have to get on with the business of the world. There are problems in the world. There are some technical problems, engineering problems, mechanical engineering, whatever, heat transfer, thermal science. They expect that you will solve those problems. So all these classes, exam, tutorial, question paper is basically for you to face the real world. Okay. Okay. Now, what we do is, so this is given like this. The first step is to calculate the residual. Okay. So please calculate the residual. I will start. Okay. So what we can do is, we can do this here. Okay. So let us do this. So you should have something called Can somebody tell me what will this be? Why did I have that extra row?
Summation, sir.
Summation.
Summation, correct. Or sigma. All right. Now, theta fit I degree centigrade. Theta I minus theta fit I whole square. So now all of you will substitute the proposal. What is the proposal? A equal to 35, B equal to 0.004. Substitute the proposal or the fit and then take values of T1 to T6 here. Calculate theta fit I, take the difference, square it, and as you keep filling, you keep telling it or come on chat and let me know. Please calculate, don't wait, don't think that it is some YouTube, some movie or web series is going on. Sir will teach and I am brushing my teeth. You can do all that. You are free. India is a free country. Your father has paid the fees, your mother has paid the fees, whatever, you do whatever you want. But if you want to learn, please work along with me. You are free not to do anything at all. Okay, it's up to you. But if you learn, if you do it now, it is fun. It is assured. Okay, because I have done it many times. Even today, I'm having this fun when I'm doing this. So the idea of a class is to just share this excitement with you. Please go ahead. Just calculate this and find out what the theta fit is. So latecomers, we're trying to fill up this table. So this is zeroth iterate. What is the first entry? Can somebody say? Let's calculate the 6 now. What is this? Hmm?
1.37.
1.37, very good. Second.
5.29.
Yes. Third.
9.48.
Good. 4.
14.92.
Very good. 5.
19.398.
Yeah. Last one.
24.373.
Very good. Yeah. Now, please evaluate the last column and get the sum. Yeah. So these temperatures are right. People who just joined in also don't worry about again start. Don't substitute it. Already it has been done. The class has done it for you. Now do this and get the sigma. The whole game is once you apply the Gauss-Newton algorithm, this S must decrease sharply with the iteration. If it is not decreasing sharply, the method is, the algo is not working. So we have to see at the end of first and second iteration. First iteration, we will do it today. Second iteration, if possible, we will do. Otherwise, we'll ask Suraj to show it how he has done it on Excel. Then at the end of two iterations, if these residuals are substantially lower than the residuals we start out with, then the Gauss-Newton algorithm is really working. Okay. Yeah, can somebody tell the values?
986.
2.985. Very good. 42.328.
328. 134.956. 221.189. 324.04.
Very good. Who is that?
Suhas.
Very good. Suhas is very much interested in inverse. 324.04 and
328.52.
okay. Now sum it up. So if the question carries, for example, because you are always interested, many of you are interested in marks and grades. If it's a 20-mark question, if you do up to this, I'll give you 5 on 6. Okay. On 20. That means first you know how to substitute it and get what is the state of affairs at the 0th iteration. So you'll get about 25% of the marks. Okay. The first step is to evaluate the residual so that you know where you are. If here the residual is 0, that means you are a very enlightened soul. Your initial guess itself is the answer. Okay. Some of you may be asking, sir, why should I do this? Suppose you hit the right answer. What is the point? There's no need to do GNA. To know the original state, you must first calculate before starting the algorithm, first calculate the residuals at the end of the 0th iteration. The initial, to start with, what is your S? What is the S? 1054?
0.07.
Very good. Okay, not bad. Not bad means what? We got the answer, but this is not very good because 1054 divided by 1, 2, 3, 4, 5, 6. But 1000 on by 6 means 6 to 4, 1. About 170. So it's about 170. It's about 170 for every value. That is, average is 170. Take the root of 170.
13.25. 13.25.
So you're having error of 13 degrees centigrade. So if you have this estimate, if you substitute this value of A and B, your theta can be as bad as it can be off by 13 degrees centigrade. It's not a good state to be in. Okay. So therefore, it is important for us to proceed from this A and B and arrive at the right values of A and B. Now, let us do the Z. Z is very easy for us. Okay. Z is basically, no. Correct. So basically, substitute the value of B and the value of time t and get this. Substitute the value of t equal to 41 seconds and b equal to 0.004. Get the second value like that. Complete this first. What is it? First column. Complete the second column. Once you get z, you can get z transpose. Z transpose is operating on z. Blah blah blah. Everything will. So first get z. Then get the forcing vector. Then say that this is the formulation. That means another 4-5 marks you would have already got. Then the 2 iterations will give you 10 marks or 12 marks for the 6 marks or 8 marks each for each iteration. Is that okay? That is the way we will. So it's not good. The cloth. Okay. Yeah, please tell me the value of Z. I'll use the full board now. Suraj. Suraj,
Sir,
why did you write as Z into Z transpose? It's not Z into transpose. It's Z transpose into
sir,
Z,
why
right?
mistake, sir? It is Z.
Mistake. Okay. You should not do that mistake, right? So Z transpose is not correct. Yes. Transpose is not correct.
Yes.
Okay. Yeah. Class, please tell me. Please note that if you're not solving the problem, you will not enjoy the class. Okay. I told you that this is my style of teaching. If you didn't like it, you should not have taken the course. So I believe that only through examples you will learn. Okay. If you just wanted theory, there are many courses available you could have taken. All right. So you'll have to work along with us. Because it is not a core course. You only decided, right? You could have taken any other course. Yeah, please tell us the. Yeah, what is the first value?
0.039.
0.0392.
Very good. I'll write the values. Please tell me whether it's all right. What happened? Normally we get about 80. Today only 60 people are there. It's 9 o'clock, or there is some other test or exam going on? Today, tomorrow? Is there any quiz? Anybody want to respond? No idea? Okay. Anyway, so are these values okay?
Yes, sir.
Yes, sir.
Very good. Now, 336.28. I hope all of you have submitted the assignment test 2. With that, we are going to close, right? So the 2 assignment tests will carry 10 marks and 20% is for quiz. So 30% is already done.
Can you extend assignment deadline, sir? We had quizzes. Many people did not submit, sir.
But for 1 hour, we gave 5 days. Rajesh, how many people submitted?
101.
101 have submitted. So what is the problem? Assignment test, right?
Submit
Rajesh?
today. I had done half of that, sir.
What is that?
I did half of that. Can I submit?
No, but you are saying that many people had. Rajesh, what is the submission you got yesterday?
101. 101.
So what you are saying is not correct. Rajesh has 101 submissions. I'm also having multiple things, right? After this class, I have to do something. There is a PhD thesis. Everybody is doing multiple things. But it takes only a lunch break to do this. Okay? It takes only a lunch break to do this because it's just 50 minutes. Of course, it's who is this speaking?
Sai Pawan Kumar, sir.
So we can always ask for deadline, but it's not like that. So you have to, tomorrow, if you're going and working in an office, if the satellite has to be launched tomorrow, you can't tell the Prime Minister, no, 6 hours, evening, some work was there, night we'll launch the satellite. It's not possible. So you submitted today, when is your lunch break?
1 o'clock to 2 o'clock, sir.
Yeah. So Rajesh, you please submit by 2 o'clock. Okay. Sai Pawan alone. Anybody else? Rajesh, note down. What is your roll number?
ME 17 B157.
17B157. Rajesh, note down. So we can accept Sai Pawan's at 2 o'clock. That's it. Anybody else? So anybody who has not submitted, do it at 2 o'clock. 2 o'clock. So what I will do is I will just give a 0 and evaluate. If somebody is falling short and is not getting a pass mark, I'll give an I grade. Then that I grade will haunt you. Okay, you cannot graduate. So then you will again write to us. So we have to do something. So what I'm going to do is I'm not going to keep on asking for this thing. We'll put an I grade. So that is an incomplete grade. So once it is an I, then you will not get the credits. Okay, so you have to do that. All right. Or if you're so confident, no, it doesn't matter. CGPA doesn't matter. Nothing matters. We'll treat it as 0. But I can't treat it as 0 unless I confirm with you. Okay. So all this will come in May. Okay, when we are actually after the exam and we are doing, then at that time we will know there'll be some 0 entries. So in this assignment, it's not possible to get a 0. So if somebody gets a 0, that means he or she has not submitted. So then we will deal with that. Okay, I don't want to deal with that tomorrow. Sai Pawan, is it okay? 2 o'clock we'll submit. All right.
Yes, sir. I'll submit.
All right. And see, you're saying that many people have not submitted. So you check your data. We are doing data sciences. You're doing. So you're speaking for yourself. You're not speaking for the class because 101 people have submitted.
Sir, I asked 2 more persons, sir. They said
Yeah.
they did not.
Yeah, with two people, you're basing a model and you're telling the prof that no, many people did not submit, which is not correct. 3 out of 101 is not many. It is it's very few. Okay. It is beyond that plus or minus 3 sigma of the Gaussian. Doesn't matter anyway. So you place the request, we are accepting. 2 o'clock is submit. All right. Anybody else who want to do that? We don't want you to replace the paper. Whoever has submitted, so be it. Somebody has not. Rajesh, don't allow duplicate submission. Is it okay?
Okay, sir.
If somebody has some genuine reason, okay. All right. So we'll also be a little bit flexible, but up to a certain point. All right. So 1217 point. Okay, 2015.8. 3151.4, 3166. Now is this okay?
Yes, sir.
Yes, sir.
Okay, now let's do I'm writing the Z transpose. Don't look at what I'm doing. Just do the Z transpose D. Also do the D vector. Let's do the D vector. Okay. See, actually, if all of you had internet and all that, right? What we could have done in ideal situation, but that would be unfair because some people are not attending. So what if the online class has to be a success, then everybody has to log in. Then we are doing this. Now at 9:40, we will send you a Google link. People will have provision for A1, A new, B new, S new, and then we'll give you 5 minutes. You'll fill up the values. Then after 15 minutes, we'll say second iteration A new. That is the way. Then the online class, but everybody has to log in. Everybody should have internet, and because we don't know what's happening outside, so and only 60 people have logged in. We can't do that. Okay. So and it will be boring only. I mean, so that is we have to live with that. Okay. So this is 0.392. Okay. Now, what is the forcing vector? That should be fun. What is the forcing vector?
1.776.
1.728. Then
6.506.
very good. Who is that? Anand? Who is that?
Subhash.
Subhash. Okay. 11 point.
11.
Okay. Is that correct, Subhash?
Yes, sir.
Then 18.
18.0.
Hmm.
18.126.
So please note that. Please note it somewhere. Put important mark, and all the students please note. In all these cases, please have at least 2 to 3 decimal places. As a general rule, have 3 decimal places because you're doing so many operations. If you just keep only 1 decimal place, when you invert the matrix and all that, it may lead to error. So keep at least 2. For safety, I would keep 3 decimal places. Okay. Unless the quantity multiplying. If it is 3166, then 1 decimal place is okay. If it is 0.1, I won't like to leave it at 0.1. I want to know whether it is 0.112, 0.101, and so on. So you understand what I'm saying? Once it's as high as 3166, whether it is 3166.70 or 71 doesn't matter. But if the quantity is very low, the second decimal, third decimal places will matter. All right. Now, please solve it. Please find delta I, delta P. So solve. So you have everything. Just it's about 9:26. Just solve it. And if somebody has nice handwriting, if you write it clearly, then I will enable the screen sharing option. You can come and tell the solution to the class. We'll be more than happy. If there is a volunteer, just write down in big letters. Write down, and then we'll wait. So anyway, 9:25. So I'll give you 12 minutes. So I'll keep quiet. So please proceed. So I will just come on chat and tell you.
Sir.
Please circulate the attendance link. No.
Okay.
Please circulate the attendance link. If anybody has any doubts so far, you can also ask now. Linear, non-linear regression, whatever. All right. So next week we'll complete the non-linear part. There are many things like Jacobi and all that. And then there's a break. Then April 6th to 12th, 11th, I will teach you the Bayesian method. That's all. Then from 12th onwards, S biology will come. Again, on the last day of the class, I will come on May 7th or 8th. I will sum up the whole thing. And then I'll put the context in perspective. I'll give a grand overview, a big flow chart of what all we have done in this course in those 40 hours or whatever, 30 hours of mine and 10 hours of S biology. So I'll give you overall grand overview presentation on the last day, and then we are done. Is it okay? So really, we don't have much time. At least I don't have much time. My portions. So today is gone. So next week, 3 classes. Then after the big 3 classes. So we just have 6 classes. There are many things to do. So I'm cutting short on some things. It was we could solve these things much faster when the physical classes are going on. So we solved many more examples last year and the year before last. But it's a pity that we have to cut down on all this because it takes a long time for you to do. Am I audible? This do you understand? Then to get your feedback, and TAs are sitting somewhere. Otherwise, we go around the class and quickly we can do many things. We can solve iterations, multiple iterations, and then before the lunch break, 5-10 minutes extra we can teach. But now the next prof will come. He will come on Zoom or Google Meet. So plenty of problems are there. Anyway, but the core concepts we have been able to teach. So I hope you will get the central ideas of the course. All right, please proceed. We had solved about 17 or 18 problems by this time last year. This time means, we must take it as May 1st week, March 1st week, because we started on January 15th last year. This time we started on Feb 1st. But we didn't miss a class. There were no holidays and so on. Even so, It is taking time. It's okay. But are you okay with the space? You're able to follow the lectures? Can somebody give a feedback? Shreyas, you want to say something? Okay. So even if suppose your audio video is not clear, you can go back and watch the recorded lectures. So we are solving a lot of problems in the class. If you're not able to solve it in the class, go back and solve it. So I think what is more important is to appreciate the key ideas. Okay. Because this is a new course, this is a very contemporary and current. And I always feel that students should be able to connect it to other courses. You should be able to connect to your interest. And so it is not just the heat transfer. This A into 1 minus e to the power of minus bt is an excuse. Okay, is an excuse to learn the Gauss-Newton. But what this grand idea of the Gauss and Newton is, the grand idea of the algorithm to approach any nonlinear problem this way is the most important thing which you have to understand. Getting it right and getting whether the answer is right or not, how much mark you will get, all that is fine. But eventually, what is it? There is a way of tackling. There's a way of tackling nonlinearity. That's what you have to understand. Okay. Okay. So is this correct? The transpose is Z. Suraj, is this right?
Yes, sir.
So it will be a symmetric matrix. It's very tricky, huh? 334041118, huh? 0.14. What is the determinant of this? Suraj, what is the determinant? Just take the calculator and calculate. Suraj or Rajesh, just calculate. What is the determinant of this? Okay, Z transpose is Z. Is this correct? And people got it? Anybody got it? Hello?
Yes, sir.
Okay, Pradeep. Pradeep Rajan.
Like I'm calculating, I got this same matrix of Z transpose Z. Now I'm calculating the determinant.
Please. Okay, calculate the determinant and then. So it is an intermediate step because we want to calculate the inverse. Determinant is very small, is it?
1.162.
Okay, 1 point.
1.16 into 10 to the power 6.
Into the power
6.
6. Okay. Now Z transpose operating on D is how much? So what is this? Two by 6. So this is 6 by 1. Is this correct? Is this correct?
Yes, sir.
Yes, sir.
Okay. So this is a matrix. So this one, this is all. This is basically Suraj's work. I'm assuming that it is correct. Anyway, the class is there to check. 33.1427. 187549. So this is also there. Okay, is this correct?
Yes, sir.
Oh, very good. Who is that? Pratiksha, who is that?
Pratiksha, sir.
Oh, very good, Pratiksha. Okay. Now, what I should do? Delta A equal to Z transpose T Z inverse operating on Z transpose T. That's it. Okay. So delta A, that is 1 by. And then that one, we can that ulta that, no? So 3 minus, minus. Okay, so this is the inverse operating on. Are the steps okay? Is correct, no? Some cofactor and all that. I think with this I'm recalling from memory. I think I'm fine. I think I'm good. Okay. 2.817. Okay, very good. Who is that? Professor Balaji to everyone. Correct. Oh, Professor Balaji to everyone is. Please note that Professor Balaji there is not me. That is Suraj Kumar. Doesn't matter. So he's using my laptop. 2.8 delta B 0051. Nikhil. Nikhil, can you show your face? Nikhil. Hello, Nikhil.
Yes, sir.
Show your face.
Internet is kind of bad. Yes.
Okay, so Nikhil, some cheers to Nikhil. Pradeep Rajan.
Yes, sir. You want me to show the camera?
No. If you come, it's okay. People will know who Pradeep is. Because he already wrote the answer. Come.
Yes, sir.
Okay, good. So it's good. At least a few of your. I'm sure everybody is following, so you're able to do it fast. Okay, Pradeep. Thank you. I think that is the answer. Okay, very good. So today I've learned something important. Whether the prof is teaching properly, whether I've understood the algorithm, all that doesn't matter. Can I do it myself? So that is the thing you have to ask yourself. Forget about marks, like this thing, exam, all that is we have to do something because you have to satisfy the world. But you have to progress. Your progress is measured by whether you are able to work. Okay. So I hope all of you got at least one iteration. If you get one iteration, that means you can proceed further. It also means that you can program it, you can code it in MATLAB, Python, R, whatever. And why only 2 parameters, 8 parameters, 16 parameters, anything can be done. Why only 6 temperatures? You can have 100 temperatures. So therefore, this gives you a framework for handling even more difficult problems. Okay. Now, Suraj.
Yes, sir.
Oh, any doubts in this? We'll wait for 2-3 minutes. Can some other people? Subhash, very good. So we'll wait for 5 minutes. Then we'll give cheers to. We'll wait for 2-3 minutes. So it's 9:40, 9:42. I will wait for 3 minutes. And then last 5 minutes, Suraj will show the second iteration. Okay, let's wait for people who are finishing. Just come on the chat and just validate the answer, whatever you're getting. Please come on the chat. And Pratiksha, have you finished? Pratiksha, you seem to be doing the steps. You didn't get it, Ma? Hello? Pratiksha, where did you go? Vikas, very good. Delta A you got. Next. Okay, very good. K Pavan, Sriraj, Kalash, very good, very good. So everybody, Pratiksha, very good. Vikas, very good. Pranay, Very good. So I think it is working. So now you know how tricky it is, how many decimal places you have to store, why you have to be very rigorous in your work, and even if you miss one number, everything will go, because you're dealing with, what are you dealing with? A combination of small numbers and large numbers, and you're cross multiplying them. Okay, so very good. Azhar, good. Azhar, Gafur. Okay. Pranay, good. Okay. So at least 12 people have got, not bad. So we're able to do that in an online environment. I'll wait for 1 or 2 minutes. Any other volunteer? Anybody who wants to show his answer? His or her answer? Okay. So, okay. Now, Suraj, are you there?
Yes, sir.
Multiple participants will. Now, that Professor Balaji, student, that Professor Balaji ka screen, you just pin it. PROA Balaji ka screen, you just pin it. Huh? Suraj will speak. Come close to the mic and you'll speak for 5 minutes. Okay, Suraj? Okay. Now, please show them the residual at the end of the first iteration. Huh? Class, please calculate the residual at the end of the first iteration. So,
Yes, sir.
where are you sharing?
Yes, sir. Yes, sir.
Share. Just go up and just show the, okay. So this is the, okay. So now just expand this. Okay. So please look at the first iteration. Little bit, we should show the time also, Suraj. Okay. Now please look at this. Please look at this. 10 seconds, 41 seconds, 79 seconds, 139 seconds, 202 seconds, and 298 seconds. Column 2. Column 1 is the serial number, index of the measurement. Column 2 is the time. Column 3 is the temperature excess. Column 4 was the theta fit for the 0th iteration with the initial guess values of A and B. We got the theta I minus theta fit I, theta I minus theta fit a whole square, and this number. That 1054, can you put it in some other color, Suraj? That 1054, that box, can you put it in some other yellow color or something? Any color, whatever you like. I want you to fill that box, not that font color. Fill that box. You know how to do that? Very good. So that's where we stand, 1054. Now come to the first iteration. Can somebody confirm the first value? Theta fit nu is 3.296. Pradeep?
Sir?
Can you confirm the first value? Pratiksha, please confirm the last value.
Yes, the first value is correct.
Okay, 3.296. The last one, somebody can confirm. Third one,
Yes,
anybody
sir.
else? Subhash. Pratiksha, last one is correct?
Yes, sir.
Very good. Okay. Now we'll assume that everything is correct. Now I am doing 3.1 minus 3.296 whole square. 11.8 minus 11.796 whole square, blah, 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 blah. So I'm taking the sum. So Suraj, show that 92.455. Use some green color box. That green color box to highlight the sum of the residuals. Okay, Suraj, what you can do is,
Yes,
Suraj, at the end of the class, convert it into PDF and then send it by WhatsApp and email to everybody. Okay? Very good. Okay. Now it has reduced from 1054 to 92. It's very good. So the algorithm is really working. Let's go to the second iteration. Okay. Now show the second iteration, Suraj. No, that you have to tell the steps. Okay. Now A became 0.004, is it? Sure, go up. No. Left side. Where are you starting? First iteration, second iteration.
Yes, sir. Starting from here, sir. This one.
ANU is 37 point, correct?
Yes, sir. First iteration, this one, sir.
Yeah, 37 point. Yeah. So how did you get the 37.81? It is 35 plus. So the delta A was plus. Okay.
Yes, sir.
37.1 and delta nu was also plus. Delta B.
Yes, sir. From here, sir.
Okay. So that was plus.
Delta A, this one.
Okay. Delta B was also plus. Minus, huh? I'm asking you something, Suraj. What is the delta B we got?
So delta B, this one, sir. 0.00512.
Okay. So you have to add it to 0.00512 to 0.004. That became. So please give the starting values for the second iteration. Where are the starting values? On the Excel sheet. Okay. So this green, whatever is indicated in green, the starting value. Okay. Now Z vector, that Z matrix. Just show them how to do the Z matrix. Okay. So this green is the Z matrix, 0.0871. So can somebody confirm the first value? Z11. Can somebody confirm the first value, which is show that 0.0871, Suraj. Go to that 0.0871. Go to the point not. It's not quite getting what. Can you just anybody confirm the first value, 0.0871 value?
It's a 0.08732. And
Yes, sir. This is correct.
Fine. So that is confirmed. Okay. Confirm the last value of 744.88. That is AT into e to the power of minus BT.
Yes, sir. Correct.
Very good. Okay. So the Z matrix is also correct. So Z transpose, if you get, you will do it. Now go to the other steps, Suraj. Z transpose T on Z is like this. Then the D vector. Just confirm the first value of the D vector. Theta I minus theta theta. Anybody can confirm the first value of the D vector. And somebody can confirm the last value of the D vector.
minus 0.1906.
1906. I said, okay, you said one. So maybe. And the last one?
7.19.
Okay. So there's some minor variation. All right. So generally it is correct. Now Suraj, show the second iteration value. Delta A, delta B. Okay.
Yes, sir.
Okay. So this is A, B or delta A, delta B?
This is delta A and delta B, sir.
Yeah. Then we may make the change. So you just say delta on that delta. So this is delta A, delta B. Now go back and calculate the residue. Okay. Okay. Second iteration. So now what are the values of A and B? I show this. 47
This is
and 0.006. Okay. So this is the show with some other color. So now A became from 35, it became 37, it became 47, and then B became 0.006. But now you can see that theta minus theta I minus theta fit I is considerably reduced to 17. Suraj, did you run on a MATLAB code with 6 iterations, 7 iterations, 8 iterations?
yes, sir. I have written.
Yeah. So what you do is you run up to 10 iterations and show the MATLAB code and the result to all of them. Some people may know MATLAB. Even if other people don't know MATLAB, you can just follow the logic. What is the programming language? What is the, how does the code look like and so on. So just do 10 iterations, Suraj.
Yes, sir. Now, sir.
And then A new, B new on MATLAB, just generate the MATLAB code with the solution and post it.
Okay.
But first things first post this one. That one you can post by the evening. Okay. So please note that anybody who is good in Python or R or whatever, you can take this as a good exercise. If the quizzes get over by Saturday, Sunday, just program it and then play with it. Start with the different initial guess and so on. And, okay. And now you will know that the effect of initial guess and this thing and many other things we will see in the next few classes. How to improve this? Obviously, this is not the greatest of all algorithms, but it's a good algorithm. How to accelerate, how to expedite the iterations, how to make it work. So obviously, how to make it work better. Obviously, there can be situations where you start with a very wrong initial guess, then the whole thing can come. And the Z transpose D Z can be a very shaky matrix because the determinant can be close to 0. If the determinant becomes 0, it's surrender. It need not even become 0. If it's close to 0, there is a problem. Wrong initial guess, there is a problem. Therefore, there's a good chance that the Gauss-Newton algorithm will not work in some cases. And also, sometimes it may be so difficult to evaluate the derivative. So under all these conditions, people have to seek alternative solutions, alternative methods for other methods to solve the nonlinear regression problem. Okay. So what we will do is we'll see what are the improvements possible. So obviously there should be a Z transpose T operating on delta A. We'll say Z transpose T plus something, which is a cooling parameter or which is a controlling parameter. It's like a damper in the spring mass system. So Z transpose T Z plus something, whole thing operating on delta A will be equal to Z transpose T on D. That something was the subject of investigation by Leeuwenberg, Marquardt. Leeuwenberg and Marquardt together, Tikhonov. Many people worked on that. What should be that shock absorber? So that shock absorber, that is a big game in the game of optimization, nonlinear regression. Many PhDs, many people have come forward to do that. Leeuwenberg and Marquardt together contributed what is called the Leeuwenberg-Marquardt algorithm, LMA. We'll see that in Monday's class. Any doubts? So I think it's already 9:55. We'll end the meeting. Thank you very much.